Okay, welcome back. Here is our example page for how to find areas of regular polygons. We're going to do triangles and squares and hexagons. Come back another day for octagons and who else knows whateveragons. Ho, 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 ho. Hi guys, this could be fun. All right. So, interestingly enough, on this one, what we're about to do, well, that's not the one I wanted, that's the homework page. So you're going to do like identical to that on here in a minute. But let me teach you how to do all of these, and you could duplicate on the other one. Okay. If you have an equilateral triangle with apothem 6, that means that if the apothem is 6, this 30, 60, 90 right here, and remember the other page, that if you have a 30, 60, 90, and this is the 31, and that's x, this will be x root 3, and this will be double x, of course. And if that's my 30, and of course that's a 30, because if you're in an equilateral triangle, that 60 gets split in half, 30, 30. So if that's the 6, that's the 6 root 3. And now the whole side will be 12 root 3. Feel free to rewind and look and watch any of these parts again. And according to the formula, 1/2 times apothem times perimeter, which maybe I'll make another video and prove to you. It's really, really cool. You could just go, oh, 1/2 times the apothem times the perimeter. Now, one of these sides is 12 root 3 because that half side is 6 root 3. 12 root 3, my perimeter is going to be, you guessed it, 36 root 3s. Now, what that's going to be is half of 6 is 3. 3 times 36 is 108. You're going to call it 108 root 3. Here is acceptable answer version number 1. Or you could go 108 times root 3 and say 187, which is about 187.061. Now, if you're saying to me, Mr. Mac, all I really want to do is find the area of this triangle and multiply it by however many I think there are, and that's 6, which is okay. Which actually, if you go 1/2 base times height, this base times height is 36 root 3. So 1/2 of that, but there's 6 of those. And that's actually the derivation of the formula right there. But there's our 187. So if you were given the apothem, that's how you do it. Now on this guy, we're not given the apothem, we're given the radius. So on this one, the radius is 6. A little bit trickier on a 30, 60, 90, but that means if my radius is 6, then my apothem is 3, but I still need this side to find my perimeter, because I need 1/2 apothem perimeter. So this side is going to be 3 root 3. Hey, look at that. That's 6 root 3. 6 root 3 for the whole side. 1/2 apothem perimeter, which is 18 root 3. So I've got 9 times 3. I've got 27 root 3s. Or if you'd rather have a decimal, you can use 46.765. I just like 3 decimal place accuracy. But if you have been given the perimeter as 6, apothem as 6, radius as 6, perimeter as 6, well, of course, if it's an equilateral triangle and our perimeter is 6, each side is going to be, you're right, 2. Well, if each side is 2, and I draw on my cute little apothem perimeter radius little right triangle here, that means this side's going to be 1. And if this side is 1, now this is a little bit weird. Ooh, this one ended up being a little bit strange, didn't it? So I'm thinking to myself, I'm going to show you a little bonus thing here in a second. That means this side is 1 divided by 3, 1 divided by root 3. That's a little yucky. Because then if it's this, that times root 3 will be 1. So that means I have 1/2 apothem times perimeter. Now this is going to be a little bit weird because it's 6 divided by 2 root 3s, which you got to be, this is like a 6 over 1, remember, like a fraction. You be really careful because now I'm just going to go 6 divided by a whole big old parentheses, 2 times square root of, square root of 3, and that will be, boom, 1.732. Now, I'd like to show you a little secret formula. Shh, secret formula. Did you know that if you want to find the area of an equilateral triangle with sides S, the area of an equilateral triangle formula is side squared root 3 over 4. What a cool formula. If you want to figure out how to prove that and send me a little explanation of that, I'll throw you a bonus point. So if I use this formula, what is my side on this one? 2. So I could just go 2 squared root 3 over 4. But 4 divided by 4 is 1. So 1 root 3. And what do you know? If I just go square root of 3, what? Exactly the same. All right, so there's the triangles. You can look back at those however you want. Now, the squares, you might say, squares are super simple. Squares are going to be nice. Well, of course squares are going to be nice because we've known them for so long. So if my apothem is 4, of course, now even you're going to look at this and go, hey, that's 8. That means it's 64. Of course it is. So I'm just going to go, since that's 4, this is 8 and 1/2. Apothem times 4/8 is 32. And 2 32s is 64. What do you know? We were right. If my radius is 4, now this is where it's a little bit trickier. Because now remember, this is a 45, 45, 90. And this is x root 2. But remember, if I've got the side as this, like I do here, I have to divide it by 2 multiplied by root 2. So each of these is going to be 2 root 2, 2 root 2. Now remember, we're going to go like 4 root 2 or something like that. But it's 2 root 2, 2 root 2, 2 root 2, root 2. And 2 root 2 root 2, 2 root 2 root 2 is 2 times 2, which is 4. What do you know? Hey-oh. So now, a little bit sneaky here because my apothem is 2 root 2. 1/2 times the apothem times the perimeter. But the perimeter, well, this is 4 root 2s because 2 root 2 and 2 root 2 is 4 root 2s. And 4 root 2s, that means I've got 16 root 2s all the way around. But this is pretty because half of 2 is 1. 16 times 2 is 32. What a pretty answer. You say, well, that was kind of an interestingly pretty answer. Is there a shortcut for that? Yes, there is. Shh, there's a shortcut for that one. Check it out. If you have a square and you know it's diagonal, and you can feel free to rewind or fast forward or whatever, but if this is 4, do you know that whole diagonal would be 8, right? Well, wouldn't this whole diagonal be 8 as well? And if you turn a square on its side, you'll notice that a square is half of a square. That was funny. But if this whole thing is 8 and this whole thing is 8, really you can just go 1/2 of one diagonal, excuse me, times the other diagonal, because 8 times 8 is 64. You're like, I don't want 64. You add all that extra stuff on. I don't want that extra stuff. Oh, yeah. So it's 32. So all you got to do is pretend it's half of a tilted square and forget about all this 2 root 2 nonsense. But I like it. Okay, you like it. Now this guy, if the perimeter is 4, easy enough. Perimeter is 4. Each side is 1. What's the area of a side with square 1? What's the area of a square with side 1? 1. 1 times 1 is 1. You're like, I need to use that newfangled formula. All right. 1/2 times the apothem, which is 1/2, times the perimeter, which is 4, and this is over 1, so 4 divided by 4. You didn't think it would work, did you? Ha! Equals 1. Whoop, whoop. Okay, part 3. Hexagons. Now, hexagons are super cool. If I want to find the area of a regular hexagon with you, I am just going to go, I need my apothem is 12. I know my radius is 12. I know my perimeter is 12, which would mean each of these would be 2. That's what I was looking for. Now, little known secret here. Little known secret. I'm going to start with this one. Did you know that a regular hexagon, is really just 6 equilateral triangles together? Here's a shortcut for you. 1, 2, 3, 4, 5, 6. Really, really pretty. So if you pretend, if the radius is 12, that means that's just a 12, 12, 12. And if I use my newfound formula here, side squared root 3 over 4, that's going to give me the area of one of these times 6. What a nice little shortcut. And if I go, that's 144 divided by 4, 144 divided by 4, and multiply that by 6, I'll have 216 root 3s. 216 root 3s. Let's see if we get that with 1/2 apothem perimeter. Of course we will. It all agrees. Okay. 1/2 apothem times perimeter. Now the perimeter, if this is 12 and there are 6 12s, 6 times 12 is 72, right? And I just need the apothem. Now let's go back and look at this triangle. Now we remember in our 30, 60, 90, I'll draw it this way this time. In a 30, 60, 90, if this is my two sides, this is my single side, this is my x root 3. So I've been given the radius, which is 12. That means this is 6. That means this is 6 root 3. Life is good because now it's just 1/2 apothem perimeter, and 3 times 72 is 216. And what do you know? 216 root 3. Bum, 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 bum. And then we can just go 216 root 3. 374.123. 374.123. If you'd like to leave it an exact, that's fine. If you'd like to leave it as a decimal, that's fine too. Where should we go? Where should we go? Well, this one will be pretty much the exact same thing, because if I know my side is 2, that means the radius is going to be 2, and that means this is going to be 1, and this is going to be 1 root 3. So you can go 1/2 apothem perimeter, or you could just do side squared root 3 over 4 with sides 2. Well, I'll do the 1/2 apothem perimeter because that is the formula du jour, as we would say en français. 1/2, that's the formula of the day. If you go into a French restaurant, ask for the soup du jour. It's the soup of the day. So I go at the 30, 60, 90, 1/2 times the apothem times the perimeter, and 12/2 is 6. That's going to be 6 root 3, which is super smaller than this one. My Lanta. Well, of course it is, because this is side length 2 and this is side length 12. It's like, this is like tiny little thing inside of there. 6 square root of 3, and I get 10.392. 10.392. Okay. And then last but not least, this guy, well, if this is 12, if I use my alternate formula, if I've given you the side here, you just divide it by root 3 and multiply by root 3, which is nice because 12 divided by 3 is by design super clean. So it's 4 root 3. 4 root 3, 4 root 3 root 3 would be 4 times 3, which is 12. This is 8 root 3, but I don't need it. So I'm going to go 1/2 times the apothem times the perimeter. Now think, if half of one of my sides is 4 root 3, the other one is 8 root 3. Now you think to yourself, ooh, I'm going to do that side squared root 3 over 4 thing with 8 root 3 as one of my sides and multiply that by 6. Sure, why not? If your goal is just to find the area, do whatever you want. So I'm going to go 1/2 times the apothem times the perimeter, and I've got 6/8, which is 48, and 6 times 48, 6 times 48, little thinking in your mind here, 6 times 48, the same thing as 6 times 2 times 24, which is 12 times 24, which is 12 times 2 times 12, which is 144 times 2, 288. Or you just use your calculator, or you just use your CalcuSooner. 288 root 3 288 root 3. What is that? 498.831. 498.831 approximately. And there is how to find the area of irregular triangles using 1/2 apothem perimeter given the radius apothem or perimeter. Regular quadrilaterals, aka squares, given the apothem radius perimeter, or regular hexagon given in the order we did it, radius perimeter apothem. So if you see a question on the homework that says find this thing, you just follow the example of what I did with one of these 9, and your homework tonight is to find the area of these 9 shapes. And these 9 shapes are exactly the same as these 9 shapes, just a different dimension to start with. So good luck. Send me any questions on Remind if you have them. Once you finish this worksheet, upload them to Google Classroom, and I will check them and grade them and perhaps send you answers soon to see if you did them right. Thanks, everybody. Goodbye.